Hello everyone, this is Arun. I am going to talk about the topic transmission media. This topic comes under the course Computer Network, which is meant for final year Bachelor of Information Technology students. And the objective of this topic is to discuss the following. Number 1, definition of transmission media. Number 2, types of transmission media. Number 3, few real world examples. Where they are being used. Okay. By the end of this lecture, you'll be able to understand transmission media and its types. Also, you should be able to choose the transmission medium for a network which you are trying to establish. So to start with, what is transmission medium? The transmission medium can be broadly defined as anything that carries information from a source to a destination. For example, two friends are having a dinner conversation. Here the transmission medium is air. I will also give another example. So let's say I want to come to KL. So the only way for me is to use an aircraft. Here the transmission medium is aircraft because the aircraft carries me from here to Kuala Lumpur. So like that, in a computer network, if one computer wants to communicate with another computer, the transmission medium is usually free space, waves, or metallic cable. Okay? Right, I hope you understand the definition of transmission medium. And if you have any questions, please raise your hands. Do you have any questions? Okay, well, so let us get into the types of transmission media. Okay. Basically, there are two types of transmission media. They are guided and unguided. So, what is guided transmission media? A guided transmission media is also called as wired transmission media, and unguided transmission media is also called as wireless transmission media. So, let us come to guided transmission media. So, what is guided transmission media? So, guided transmission media provides cable to transport data from one device to another. So, this type of communication is also called as wired communication. So there are three types of cable under guided transmission media. One is twisted pair, number 2 coaxial cable, number 3 fiber optic. Okay. So let us begin with twisted pair. So what is twisted pair? Twisted pair cable consists of two copper conductors twisted together, each with its own plastic insulation. So like this. And at the end of this, you have conductors, two conductors. Okay, you can see consists of two copper conductors twisted together, each with its own plastic insulation. Okay, and one wire is used to carry signals to the receiver, and the other is used as a ground reference. Right. So as you can see, I got this twisted pair cable. Okay. So you can see two conductors, 1, 2, twisted together with its own plastic insulation. So here is the plastic insulation, and you have two conductors twisted together. And in this cable you have 4 twisted pair, 1, 2, 3 and 4. Okay, this cable is called as Cat 5 cable. Mostly you can see this cable at the back of your CPU. Okay, we'll call it as a LAN cable, but actually it's a twisted pair cable. Okay, right? So why it is twisted? That's very important. To avoid noise or crosstalk from interfering with signals. That's the reason it is twisted. Okay. So for example, there is a noise over here. In one twist, one wire, that is this wire, is closer to the noise, and the other is bit farther from the noise. Whereas the next twist, the reverse is true. Okay, so twisting makes it probable that both wires are equally affected by external influences and hence mathematically nullifies the influence. So if the number of twists increases, the quality of the cable will also increase. So more the twist, more the quality. Okay. Right. So twisted pair cable is further classified into two types. One is shielded twisted pair and another one is unshielded twisted pair. So shielded twisted pair has a metal foil that covers each pair of insulated conductors, whereas unshielded it is not. So the one I have here, right, is unshielded twisted pair. Okay, whereas in shielded you can see some metal foil that will be covering this insulated sheath. Okay, but I don't see unshielded twisted pair in the market. I see only twisted pair in the market. So these cables are used for constructing local area networks. Now let us see the categories of twisted pair. There are 7 categories. Okay, 7 categories of twisted pair. It starts from Cat 1 and it goes till Cat 7. Cat 1, it transmits the data at the rate of 0.1 Mbps. 0.1 Mbps. Normally it is used for telephone lines. Okay. Then Cat 2, it transmits the data at the rate of 2 Mbps. Cat 3, it transmits the data at the rate of 10 Mbps. Cat 4, 20 Mbps. Cat 5, 100 Mbps. Then you have Cat 5e. This is 125 Mbps. Just now I told you that the one I have is Cat 5e, so it transmits the data at the rate of 125 Mbps. I think this cable is suitable for constructing a local area network of size 800 computers or 900 computers, because I'm using this cable for my local area network of size 710 computers. Okay, so it carries data at the rate of 125. It's enough for constructing a LAN, okay, mid-size LAN. Then Cat 6, so the data rate is 200 Mbps. And finally Cat 7 here is 600 Mbps. Okay, so these are the categories of twisted pair. When it comes to connecting a twisted pair cable to a device, we require RJ45 jack, and this is the one. Okay, you can see this is RJ45 jack. Okay. So this RJ45 jack is used for connecting twisted pair cable to a device. So I will give you a demo. So I have a laptop here. Now I'm using RJ45 connector to connect. Yes, it's done. Okay, right. Okay, so that's what this connector is used for, connecting twisted pair cable to a device. So coming to some real world examples of twisted pair. Normally the telephone cables that you are seeing at home is a twisted pair cable, and mostly it's of Cat 1 cable. And if you have internet connection, the LAN cable that is connected to router or at the back of your CPU is a twisted pair cable, and it's mostly of Cat 5e. Okay. Now let us come to coaxial cable. Okay. Coaxial cable is quite different from twisted pair. Here, the cable has a central solid core conductor. First, I will draw a coaxial cable. So this is the one, that the solid core conductor. Okay, and it is enclosed in an insulating sheath. So we call this as an insulator, which is in turn enclosed, you can see, enclosed in an outer conductor of a metal foil. This is an outer conductor of metal foil. Okay, this metal foil provides shield against noise. Okay, and this outer conductor is also enclosed in an insulating sheath. We call it this as an insulator. And finally, the whole cable is protected by a plastic jacket or plastic cover. So coaxial cable has a central core conductor surrounded by an insulator, which is in turn enclosed by an outer conductor of metal foil. Metal foil provides shield against noise, and this outer conductor again is surrounded by an insulator, and finally the whole cable is protected by a plastic cover or plastic jacket. Okay, so there are three categories of coaxial cable. They are RG59, RG58 and RG11. Okay, RG stands for radio government, and this RG59 is used for cable TV, RG58 is used for thin Ethernet, and RG11 is used for thick Ethernet. Okay, these are the three categories of coaxial. So to connect coaxial cable to devices, we need coaxial connectors. Okay, there are three popular connectors are there. They are BNC connector, BNC T connector, and the BNC terminator. And BNC stands for Bayonil concealment, and I will show you connector. There is a BNC connector. You can see it's a BNC connector, and I will also show you a coaxial cable. And this is the coaxial cable. This is the coaxial cable. You can see this. Okay, you can see center solid core conductor and surrounded by an insulator, and after that it's surrounded by an outer conductor, and then it is surrounded by an insulator. Finally the whole cable is protected by a plastic cover. This is a plastic cover. Okay, so just I'm just going to attach this BNC connector to this coaxial cable. Okay, now it is getting attached. Okay, so BNC connector is used for connecting coaxial cable to a device. So now that the cable is ready, now I need to have a device. So here is the device. Okay, it's a set-top box of a digital TV. So I'm just trying to attach this cable to this device. Yes, it is getting attached. Okay, so now you can see this cable in your home, and you can see this set-top box also in your home. So you are using BNC connector to connect your cable to a set-top box. Okay, right. Now let us come to fiber optic. This is the last guided media. A fiber optic cable is made of glass or plastic and transmits signals in the form of light. Okay, So there is a difference between fiber optic cable and twisted pair coaxial, because the difference is twisted pair coaxial cable transmits signals in the form of electric current, whereas fiber optic transmits signal in the form of light. Okay, so I will draw a fiber optic cable and I will explain that. You have an outer jacket. Inside the jacket you have a Kevlar material. It's a strong material that strengthens the cable. Okay, this is an outer jacket, and inside the jacket there is a material called Kevlar. It is used to strengthen the cable. Okay, and below Kevlar there is a plastic coating. This plastic coating is used for cushioning the fiber, to cushion the fiber. Okay, and from there comes a fiber cable, and this is fiber. Okay, and it consists of cladding and glass or core. Okay, this is fiber. It consists of cladding, glass or core, and this is plastic coating. It is used for cushioning this fiber, and above plastic coating there is a material called Kevlar, is used to strengthen the cable, and above Kevlar there is an outer jacket. So this is how fiber optic cable looks like. Okay, and in fiber optic, ST connector is used for connecting cable to networking devices, and SC connector is used for cable TV. So I can show you a sample connector. So the connector looks like this. Okay, it's like a push and pull locking system. So coming to some real world examples of fiber optic. Fiber optic cable is often found in backbone networks and can transfer data at the rate of 1600 Mbps. And some cable TV companies use a combination of optical fiber and coaxial cable, thus creating a hybrid network. Optical fiber provides the backbone structure, while coaxial cable twisted pair provides the connection to the user premises. So I think fiber optic is far better than twisted pair and coaxial cable. But twisted and coaxial, I think normally you will be seeing in subscriber premises, whereas fiber optic you will be seeing as a backbone network, I think mostly used by telephone companies. So we have seen three cables, and now we will compare fiber optic with twisted pair and coaxial. So fiber optic has several advantages over metallic cable. Fiber optic cable can support higher data rates than twisted or coaxial cable, and it transmits fiber optic transmission distance is greater than that of other guided media, and a signal can run for 50 km without requiring regeneration, whereas in twisted and coaxial we need repeaters for every 5 km, and electromagnetic noise cannot affect fiber optic cables. But there are some disadvantages in using fiber optic cable. There is fiber optic cable installation and maintenance require expertise that is not yet available everywhere. And the second thing is the cable and the interfaces are relatively more expensive than those of other guided media. So now let us come to unguided media. So unguided media are those that uses electromagnetic waves for transmitting data, and this type of communication is often referred to as wireless communication. So unguided media are of three types. One is radio wave, microwave, number 3 infrared. Radio waves are electromagnetic waves ranging in frequencies between 3 kilohertz to 1 gigahertz. Okay, and these waves are omnidirectional. This means that the sending and receiving antennas do not have to be aligned. Suppose a sending antenna sends waves that can be received by any receiving antenna. So let's say you have this, and like is omnidirectional. The sending antenna sends waves that can be received by any receiving antennas. But radio waves, particularly of low and medium frequencies, can penetrate walls. Now let us see the real world applications of radio waves. If you are listening to AM FM radio for a song, the song is reaching us in the form of radio signals. Let's say incoming and outgoing calls of a cell phone is using radio signals for transmission. Whose cardless phone in our home is using radio signals for transmission. And the second unguided media is microwave. Microwaves are electromagnetic waves having frequencies between 1 gigahertz to 300 gigahertz. Okay, but microwaves are unidirectional and it needs line of sight propagation. This means that the sending and receiving antennas need to be aligned. That is, you have two towers. Two towers with the mounted antennas need to be in direct sight of each other. Any obstacles between towers do not allow microwaves to transmit. So this property of microwaves allow a pair of antennas can be aligned without interfering with another pair of aligned antennas. And microwaves need unidirectional antennas that sends out signals in one direction. So microwaves normally use two types of antennas. One is parabolic. Another one is horn. Okay, so parabolic normally it will be looking like this. Okay, so parabolic dish works as a funnel. It's like a funnel, catching a wide range of waves and directing them to a point. Okay, it's like a funnel catching the wide range of waves and directing them to a point. Whereas horn antenna looks like a gigantic scoop. So received transmission or collected by the scooped shape of the horn in a manner similar to the parabolic dish and are directed down into the stem. So microwaves are used by satellite networks and wireless networks. And finally, the last unguided media is infrared. So infrared waves with frequencies from 300 gigahertz to you have 400 terahertz. Okay, and can be used for short range communication. And because infrared has got higher frequencies, cannot penetrate through walls. And mostly this property of infrared waves prevents interference between one system and another. For example, when we use our infrared remote control, we do not interfere with the use of the remote by our neighbors. So in addition, we cannot use infrared waves outside a building because the sun's rays contain infrared waves that can interfere with the communication. And coming to some real world examples of infrared, wireless keyboard mouse communicating with PC is using infrared waves. TV remote is communicating with TV is using infrared waves. So finally this session has come to an end. Before I close this session, I would like to summarize what we have discussed so far. So we have discussed transmission media and its types and few real world examples where they are being used. So in the next session we will see how to construct a small home office LAN using guided and unguided transmission media. So it's going to be a practical session. So thanks for listening. Bye. Have a good day. Thank you.